Hello everyone, and thank you for joining us for this first video for this series, including interviews to people who have been using Fantasia for their research. And our first guest is Maria Di Maro, who is my friend and colleague from the University of Naples, Federico II. Maria is a PhD, has a PhD in Computational Linguistics, and today she will be talking about her research, and she will show us how Fantasia was used during her PhD thesis to perform her experiments. So thank you, Maria, for joining us today.
Thank you, Antonio, for inviting me, and everyone who's watching this video. So yeah, today I'm presenting basically what was my work in my PhD, what I started during my PhD and what I'm working on today. So my focus was actually on common ground management in dialogue systems, and what I wanted to find out was what kind of questions can be used by such a system to disentangle inconsistencies in the common ground. So the basic concept of my research was common ground inconsistencies. First of all, let's define what common ground is. In pragmatics and in conversation analysis, we talk about common ground to refer to the set of shared knowledge among the participants to a conversation. And common ground is very important because conversation is always considered as a joint activity. And this means that during the conversation, the interlocutor must ensure that there is this set of knowledge to be sure that the understanding can actually work. What is common ground inconsistencies? This is basically what happens when somebody thinks that a knowledge, an information is already shared in the common ground. Like here, we say something like melt the butter, then add the milk, and other information that are provided by one speaker to a listener. But at a certain point, another statement, another utterance can be provided, like now you can cut the butter. This information, this new information, actually clashes with the previously grounded information because the butter was melted and now we cannot cut it if we imagine that we use the entire butter, the whole butter. And this is when we can use something like this, a clarification request in the form of I negation polar question, like wasn't I supposed to melt the butter? This is the clarification request that we can actually use when a common ground inconsistency occurs. So these clarification requests were described as common ground clarification requests. Before giving some details about this type of clarification request, we need to define what two different types of common ground are. So the communal common ground and the personal common ground. The communal common ground is the set of knowledge which are shared between the participants to the same community, whereas the personal common ground is the set of information that are shared during the interaction. We have here an example. So imagine that we have two different agents. One is giving the information to the other. So first of all, the information that are given by agent B on the right side of this picture are processed, we can say, by the other agent. And each information can become part of the personal common ground of this agent if, of course, this information also respect, we can say, the rules of the communal common ground. So if an action is actually possible, like cut the butter, we know that we can do this action. After different information are stored, we can have an information that might cause problems in the future during the interaction. We can go on with interaction, and then another action, another information is provided, and this information actually clashes with the previous one, here E3. At this point, a specific clarification request, as the one we saw in the previous example, can be altered, and this clarification request has a specific form that explicitly refer to the information that caused the inconsistency. So what were the research questions? The first one was the following: which form of question was more appropriate in common ground inconsistency scenarios? And based on different experiments that were carried out, we found out that I negation polar questions are mostly used when we have a positive bias, so strong belief that something was already grounded, and negative evidence, so a proof that actually what was grounded was not true. Then the second research question: can the adoption of these kind of questions improve usability and naturalness in human-machine interaction? And with other experiments, we discovered that this is true, because the adoption of I negation polar questions actually led to a much usability, higher usability and naturalness. The third research question: how can common ground inconsistencies be represented in computational architectures for dialogue management systems? In this case, we actually used FANTASIA, and we'll explain later how this was done.
So, thank you, Maria. And to represent knowledge in your thesis, you used graphs, right? You used
Yes.
graph databases. So, would you please tell us more about the knowledge representation part of your thesis?
Yes. We have here what was called conflict search graph. This graph was modeled in Neo4j. And in this graph, we were able to represent the dialogue history of the interaction. So the information, as we saw in the previous examples, the set of information, the sequence of information collected during the interaction. So basically the personal common ground. But on the other end, we were also capable of representing the domain, which was used to also find possible conflicts within the interaction itself. To do that, we used different sources. First of all, we have FrameNet for domain-dependent action representation. This means that each action was semantically represented using the frames as they were represented in FrameNet. And on the other end, we also used Wikidata for the representation of the item used in this specific domain, which was the cooking domain. Neo4j, on the other end, was used to represent all this information, but also to be used as a kind of inferential engine to extract the possible conflict during the interaction. Here we have the representation of the communal common ground, so the representation of the domain and how it was represented. In this case, we have here the dialogue domain, which is the one of cooking. For each dialogue domain, in this case this one, we have the different frame instances, and for each frame instance we have the specific frame node. In this case, here we have represented the frame of reshaping. For each frame, there are also the frame elements, which can be defined as the argument, the semantic arguments of a concept or of a verb mostly. And for reshaping, we have, for example, patient, result, and instrument. For each of these frame elements, we also have a specific constraint, meaning that each frame element can be of a specific type. In this case, what can be reshaped is an ingredient. This ingredient is the domain element in this case, and each domain element is represented by Wikidata instances and Wikidata classes. So this means that all the possible ingredients are also represented in the database. This is what happens at another level, at the level of the personal common ground. So imagine that we have a user. This user utters an action, declares an action, like grind the nutmeg. This action is a frame instance, which is here represented with its ID. And this frame instance is instance of the frame grinding that belongs to the domain of cooking. This frame uses a specific frame element, which is here patient, because we have something that is grinding. And this patient refers to the identity noce moscata nutmeg. This entity is then collected to the perceived entity, which is the entity created for this action. And here the nutmeg has a specific precondition, which is that of being solid, but after the action of being ground, we have a nutmeg which is no longer solid but powder. So once we have a new action, which is uttered, which is again grind the nutmeg, this action is not possible because we have here nutmeg which is no longer solid but powder, and therefore the action that caused the nutmeg to be powder and not solid is identified. To do that, we used queries in the Cypher language, which is the query language used in Neo4j. And in this specific query, we asked to, first of all, define what quantity of a specific element, a specific item, was defined. So was it entirely used, or was for example, a quantity specified during the interaction? If there is no longer, if the item, the element is no longer available, it means that the action cannot be performed. And from this query, we return these elements. The evaluation, which is here false. So we have Boolean value that tell us that this action is not possible, and as we'll see later, this enable us to create also to generate also a response in the system, like I can't perform this action. Then we also have the natural language explanation that can be built by with the information retrieved from this query. Like, I don't have enough of this perceived element, which is here retrieved. And then we can also return the conflictive frame. So the frame, the action that caused that perceived entity to be no longer usable. And then we can also retrieve the original entity to create, to generate our responses.
Okay, so Maria, why is this important for embodied conversational agents? Why is it important for embodied conversational agents to be able to correctly communicate the errors that they find while they're interacting with people?
Yes, it is important because with our experiments, we also highlighted how the usability of the system can be improved And specifically with our experiment, we found out that with the use of that specific clarification request, the mistake by the user could be easily
Retrieved.
huh?
Retrieved,
identified, yes. And of course, in this way, the error could also be, how can I say that?
Help the people to resolve the issues, recover from the issues.
Yes.
Okay, so it has its applications mainly in system recovery. So when there is an error, you can provide better information messages to let the user resolve the error, right?
Yes, you know better than me.
No, that's not true. Okay, so now let's jump into Unreal. And Maria, please show us how you implemented your embodied conversational agent, which is called Bastian.
Yes. Okay, here in Unreal we have the blueprints. In this first block about natural language manager, we have the first event, start listening, that activates the natural language understanding that is connected to Microsoft Azure Lewis. And from here we can retrieve the top intent, the confidence of this intent, and the entities which are represented first as arrays, and then they are transformed into dictionaries with entities and type of entities. Here these entities are used to build the frames, which are then used to add the information in our database. This happens here where we have the frame name, and the frame confidence. And this is done by using these queries. And it is important to point out that each action that is saved in the database in this way is firstly treated as a transaction, because in Unreal we know that these transactions are used when we want to first represent something as an hypothesis to verify how this action, which is saved in this way, will affect in the future the system itself. Then this transaction is used here, where the entire information on there and then connected to the common ground, because previously the information which were saved were basically the action, the frames, structures, and the entities. But here we also have the perceived entities, which are already part of the database. This is a single query that is used to do that, and it is this information is just added to the transaction. Then, then we first check for the preconditions, and here we just use one query that is generally applied to check for preconditions, and again this is done as a to the transaction. After verifying the preconditions, we consolidate the common ground, and to do that we also use queries. First of all, if everything goes right, the transaction is committed, it is concluded, and this means that we can close the transaction. We have an action which is saved in the personal common ground, and the post conditions are also added to the perceived entities. And this also ends with the generation of a response like, okay, I confirm that I can go on. If something goes wrong and so the precondition is not verified and an inconsistency is identified, we need to we need first to cancel the transaction. We have a rollback of the transaction, and then the explanation and possibly also the clarification request can be generated. To generate the explanation, we first use a string like I can't, then we say why we cannot perform that action, and this is retrieved from the previous queries where the precondition was verified. And for example, if I cannot melt the butter, it's because it is already melted. And then we close the explanation. If also the action which caused that inconsistency is retrieved, and we identified the conflicting frame corresponding to that action, we can use this information to generate our negative polar question to ask for clarification. And this is also this is then processed by the TTS, the text-to-speech module.
Okay, so let's see this in action, Maria.
Yes.
And let's see how Bastian reacts to you giving commands to it.
Ok. Trita la noce moscata.
Va bene.
Now imagine that I can also utter more than one sentence in between, but if I repeat the same action now, trita la noce moscata.
Non posso. Noce moscata è in polvere. Non dovevo tritare noce moscata?
Here the conflicting action was identified, and the explanation, the clarification requests were correctly used by Bastian.
Perfect. So Bastian is actually capable of using negative polar questions in the correct way to provide an informative representation of the error, right?
Yes.
Perfect, that's great. Typically, error messages are confusing for the people, so every attempt to improve how they can help the user solve the problems is welcome, I think. So your work is very important in this sense.
Thank you.
So, thank you, Maria, for joining us again.
You.
Thank you for showing us how you used Fantasia in your research, and we look forward to hear more from you in the future.
Thank you.
So thank you everyone for listening, and I hope you will keep following our channel about Fantasia.